What's going on, y'all? I am filming this on Thursday, April 23rd. You should all be watching it on Friday, April 24th. Hope everybody's having a great week. We just got off the Zoom call. I had my Mario hat on before, I think. Hence the mustache. Boom. So we are on lesson 9 today, some angles. We're going to be taking how to find angle measurements and learning what we do when we put them together, okay? In order to be on lesson 9 in Zearn, you must have finished 1 through 8. If you haven't yet, go back and finish them. Remember, I'm checking. If you haven't done your Zearn lessons and if you haven't done your exit tickets, you are getting a 0 in the grade book. I'll replace it with your actual grade once you finish the assignments, but I need to see that you do them first. So get to work, and if you need help, reach out to me. I think these videos will be really, really helpful if you go back through the assignment information and rewatch them. All right, my friends, our objective for today. Let's go to lesson 9. Students will be able to decompose angles using pattern blocks. So when they say it's pattern blocks, what they mean are shapes. So we're going to go over a bunch of different shapes. We're going to learn how to find the degree measurement of angles within those shapes and what happens when we press those angles together. Once again, y'all are on your own for fluency. I think at this point we should feel really confident with this. I want you to do the number gym and the Discovery Canyon on your own. I'm going to start off with the learning lab, and then we will do the Tower of Power. Like the last video, I heard from a bunch of friends. They said that when I went over the exit ticket, I gave you a few tips and tricks on that exit ticket at the very end. They thought that was really helpful too, so we'll wrap this video up with that. All right, let's get right into our learning lab. All right, let's come out. So what it did, I've been doing a little bit of these on my own as I get prepared to do these videos. So I think it started me in the middle of one. Let's come back out here. All right, so what I'm going to do. All right, y'all, here we go. All right, our warm-up question. How many degrees is in a full turn? We talked about this in lesson 8. If I start standing, facing forward, I turn all the way around. One full circle, one full rotation around the clock. How many degrees? Go ahead and put your answer in. If you said 360 degrees, you were correct. Nice job. A full circle measures, around our circle, measures 360 degrees. How many right angles meet at central point Y? Well, here's our central point Y right in the middle. And if we look at the angles that touch that vertex, there's 1. These are squares, so we know the corners are right angles. That means these two lines, this line running down and this line running horizontally, right, vertically and horizontally, those are perpendicular lines. When they cross, when they intersect, they make perfect right angles. So how many right angles did we have there? Go ahead and put your answer. If you said 4 right angles, you were correct. 1, 2, 3, 4. Look at angle XYZ. XYZ. This angle in the corner marks XYZ. Is that a full turn, a quarter turn, or a half turn? Well, a full turn would be all the way around this point, this central point. And we're not going all the way around. We're just using this upper right-hand square. A half turn would be these two squares put together. So it would be around like this. So this leaves us with one possible option. Go ahead and select it. If you said a quarter turn, you are correct. Nice job. And this is 1/4 because it's 1 out of 4. 1/4 is the same as 1/4. I like to think about it like money, right? If you have 1/4, you have 1/4 of a whole dollar. All right, and that measure is 90 degrees because it's just one turn. It's just a quarter of a turn. One right angle. Nice job. All right, angle XYZ is 1/4 turn and it measures 90 degrees, just like we investigated. How many quarter turns are there around the central point Y? The central point Y. All right, well, I want to know how many total this would be if I went all the way around it. How many quarter turns would there be? If you said 4, you're correct. 1, 2, 3, 4. All right, so that means if there's 4 quarter turns, we'll have 4 angles. Each angle, these are perpendicular, so the angles must be right. That means each angle is 90 degrees. What we're doing here is we're creating an addition sentence for the sum of the angles around point Y. So what is the sum of these angles? Sum is the name of an addition or sum is the name of the answer to an addition problem. All right, when we add these up, I like to just do 9 times 4 and then tack a 0 on the end. 9 times 4 is 36. We have a 0 on the end, 360. Very good. All right, my friends, our next question. What is the measure of angle A, B, C? Use scratch paper if you need to. I want to know what you guys think. So if you're looking for just this angle here, you have to start by thinking about the shape. So what shape is this? If you know the shape without looking it up on Google, because you know Google could just give us the answer really easily, go to Google Classroom and tell me what it is. You can pause the video now if you want to go write that in. Okay, you're back. If you said a hexagon, you're correct. Hexagons have 6 sides. We can count 1, 2, 3, 4, 5, 6. But they don't want us to find any of these angles. They want us to find this angle right here of just one of these. It looks like this hexagon's decomposed into 6 triangles, and they all look like they're the same shape, the same size, I should say. So when we take a look at it, what strategies can we come up with? What do we think? If you have a really good strategy, and you might want to, this is what I want you to do. If you have a strategy to find this angle, pause the video and see if you can come up with it on your own. All right. You could even plug it in. It'll tell you if it's correct. And then in Google Classroom, in a private message, write the name of that strategy, describe the strategy to me, and I want to see if you got it the right way, or if you got it, there might be multiple ways, but if your way gets you to the proper solution. You can pause the video now and go ahead and try. All right, you're back. Nice work. So we know we're looking for this one angle here. We have our vertex right there, our central points here. Now, if you notice, this is what I did. I can see I have a circle here. So around the circle, we know how many degrees that is. We've gone over it for 2 days. If we make a full turn around a circle, we have 360 degrees. So this angle must be a piece of 360. Well, how many triangles do we have here? It looks like it's a hexagon. So 1, 2, 3, 4, 5, 6. So I need 1/6 of 360. 1/6 of 360. So remember, when we have a fraction of a set or a whole number, it's like a division problem. So I'm doing 360 divided by 6. You could do long division. I'm not going to. I'm going to do quick division. So I can take my 360 and just do 36 divided by 6. 36 divided by 6 is 6. Nice work. And then we have a 0 on the end on our front number. That means we plug a 0 on the end of our front number, 360. So I plug that 0 right on the answer to my division problem. That means each of these angles is is measured at 60 degrees. 60 degrees, 60 degrees, 60 degrees, 60 degrees, and 60 degrees. When I add them all up, they will equal 360. If you don't believe me, double check. And our answer is, let's plug it in, 60 degrees. Nice job. I'm so excited to see your answers. I want to see what you guys got for this and what strategies you used. All right, and we can see from our protractor here, we start at 0 and we measure up to that angle. We have 60 degrees. It checks out. Nice job. All right. Ooh, a new angle. But we know they're the same triangles, right? This hexagon was split into 6 of the exact same triangles. So this angle right here must also equal 60 degrees. Let's check. You got it. Nice job. What if we combine them? What if we put these two angles together? It creates a new angle, a much wider angle. To find that measurement, what do you think we have to do? Write your strategy down. I want to see if you can find it. Oh, and look at that. It's right on the page. Write an addition sentence for the measure of the unknown angle. It's an addition sentence to find the total. You have to add it together. 60 plus 60. Nice job.
Nice job coming up with an addition sentence.
Right.
Lucas,
see you in a second.
How'd you do this one? The sum of angles around.
Remember, my friends, you are watching these videos. They're short, like 30 seconds long, 45 seconds, a minute max. I'm going to go to the next problem set. I'll see you all in a second.
On the central point.
We know that each of the 6 angles around the central point is 60 degrees. I wrote the addition sentence, 60 degrees plus 60.
All right, my friends. So what we're going to do here, we are going to combine some shapes, and we're going to see if we can find the total, the sum of the angles when they're pressed together. So what you're going to do, you're going to spin this wheel. You're going to spin the second wheel. All right. Our first shape, it looks like it is a square. Our second shape, it looks like it is a triangle. When you do this, you might have different shapes, which will be really cool. I'd like to see what you get compared to what I get. All right, so they put them together just like this. Notice the angles are touching here, and that makes a new angle, H-I-J. Up here, we have the different angle measurements for our triangle, for our square, and for our hexagon. Write an addition sentence to measure for the measure of the unknown angle, H-I-J. So we want to plug in this angle here. Let's look at one of these. It looks like one angle in that triangle measures 60 degrees. For our square, we can see that one of these angles is right. That means it's 90 degrees. When we add them together, we get 150 degrees. Nice work, my friends. All right, let's just use a protractor really quick to double check. So we start here, 0, and we're going to measure around to 150. It checks out. Notice the angle here. I'll do it in blue. Not perfect, but you can see that's our angle. Here's the arc that denotes the angle. This is true. Nice job. All right, let's do it again. I'll go ahead and spin the first one. Hopefully we get different shapes. We got a triangle. Let's root for a hexagon. Yes, nice. All right. Let's try it out. All right, notice how they put them together there. That's pretty cool. Look, the triangle fits right in this little groove here. I love geometry. One of the cool things about geometry and shapes is that, and especially triangles, right? Equilateral triangles where the sides and all 3 angles have the same measurement and all 3 sides have the same measurement. They really fit nicely and they're kind of fun to play with. If we're back in the classroom this year, we're going to have a lot of time to play around with a lot of these shapes. Okay, write an addition sentence for the measure of the unknown angle. I want you to solve your own and then check out mine. All right. If you said here we have 60 degrees And for our hexagon, we have 120 degrees on the edge here. When I add those together, we'll just add them quickly. 6 plus 12, that's 18. I'll tack a 0 on the end because we're working with our 10s, not our 1s. 180 degrees. This angle here, our new angle, measures 180 degrees. What do you notice about that angle? We'll do it in green. What do you notice about that angle? What do you observe? Observe. If you observed that it is a straight line, that's a great observation. It's very poignant. All right. Our straight lines always measure 180 degrees. All right. Always 180 degrees. Start to lock that into your memory. We're going to use that as we move forward. All right. When we measure this out, we can see from 0 all the way over to 180. That checks out with our protractor. Let's click yes. Nice work. All right, look at the blue angle labeled NOP. I think they mean this outside blue angle here, not what's inside. Which two shapes could be used to measure NOP? Let's get a good look at each of these angles. Okay, it's a little bit more. Seems like it's a little bit more than 90 degrees, each one. So these angles, these are acute. It looks like these are all smaller than 90 degrees, so that won't work. And we know for a square, these are perpendicular lines, which make 90-degree angles. These are right. So those are exactly 90 degrees. We need angles that are larger than 90 degrees. We need obtuse angles. This isn't true. So it looks like our hexagons here are the only shapes that can slot right into these two places and create our new angle. You got it. Nice job. All right, let's write an addition sentence for the measure of the unknown angle NOP. This measures 120, this measures 120. Pause the video right now. Go ahead and solve this quickly. 120, 120. When I add those together, what do I get? If you said 240, you are correct. Again, I like to do 12 plus 12. That's 240, but we're not working with our 12s. We're working with 120, so make sure that 0 is on the end. All right, and our protractor confirms. Notice from 0, let's stretch out these lines a little bit. From 0, I'm going to measure around right to here, and it looks like this is indeed 240 degrees, so it checks out. Scroll down the page, use a protractor to prove that angle NOP measures 240 degrees. Yes, sir, it does. Let's keep it moving. Nice job. Oh, of course we're ready for more. Let's handle it. All right, what shape can you create? What shape can you add to create a straight angle? So I want to create a straight angle. Now you might have a different problem. I think these are mixed up here. But if we want to create a straight angle, should I plug this one in? Will this piece give me a straight angle? Will this angle of this triangle give me a straight angle? Will this square, will this hexagon? What do we think? Well, I think this square, this 90-degree angle, will fit perfectly right in here. Let's see if that's correct. Nice job. We did it. And we earned it. All right, guys, good luck on that. Make sure you stick around for this video. I'm going to slide right on over to the Tower of Power. I'll give you some hints there, and then we're going to go right on to the exit ticket. If you want to pause this video and move around and do some things on your own and check back in, that's totally fine. But I do recommend checking in on these videos. I will give you some helpful hints on those exit tickets. All right, Tower of Power time. Let's do it, y'all. All right, here we have 4 shapes up top. What shape is this? If you're thinking triangle, nice job. What shape is this? If you're thinking square, good work. What shape is this? A hexagon. Good memory. And last but not least, what shape is this? Well, we didn't do this one. So if you know it, if you know this last yellow shape, send me a message on Google Classroom. I'll be very impressed if you know it off the top of your head. If you don't know it, I'll tell you at the very end of the video. All right, let's keep moving. So we have our two shapes here. What angle do they form? Well, we know one of our hexagons has each angle measured at 120 degrees, and we'll call this a quadrilateral. It's got a couple other names, but I'll label it a quadrilateral for now. This quadrilateral here, we plug the 45-degree angle in. So when I stick them together, it creates a new angle. What is the measure of that new angle? Well, we'll use our addition to find that. 120 plus 45. 120 plus 45. We should be able to do this very quickly. 0 plus 5, everyone? Yes, 5. 2 plus 4, everyone? Yes, 6. Slide that 1 right into the hundreds place. Our answer, 165 degrees. Good work. Let's keep climbing. All right, which shape, our question's at the very top, which shape can you add to create a straight edge? So we need to put a shape right here. What shape can I slot in right there to create one straight edge or one straight line? Well, let's see. This looks like it's a little bit too wide. Our 90 degrees won't fit here into this little spot here, MLN. These guys are too wide, 120, even 60. I think we could like maybe shoehorn it in, but it wouldn't fit neatly and nicely. I actually think this quadrilateral here will fit in perfectly to create our straight line with this edge. Let's see. Enter. There we go. Excellent. You got it. Nice work. All right. All right, my friends, you might have a couple more questions. That's totally fine. I'm going to add a bunch of questions into your exit ticket. What we'll do for the exit ticket, hang tight, and I'll slide back over there. I want you guys to go to your Edge Elastic now, and I'll see you in a second. All right, my friends. We're on Edge Elastic now. Yours will look a little bit different than mine. Thank you for my friends that stuck around in the video. You're going to get a really, really big boost here on your exit ticket. Before we do that, the name of that shape, that yellow shape, is a rhombus. I'll be checking to see who got that. All right, let's go through a few of these questions. I won't be giving you the answers, but I'll be giving you some helpful hints and tricks. For question 1, part A, in the following figure, which equation will find the measure of angle POR? So they don't want to know POT. That would be this whole measurement here, the entire thing. They want us to find POR. So which one of these three equations will give us the sum of those angles? Okay, so really look closely that you're measuring for this angle here, POR. What angle does that make? All right, for B, sort of an extension question. In the right angle below, the measure of angle X is what? You need to know what degree measurement is a right angle. If you need to find this missing piece, this entire thing needs to be 90 degrees. What can we put here to make it 90 degrees? What operation helps us find the missing piece? I need you to think about it and try your best. All right, question 2. The measure of angle EFG shown below is 106 degrees. Similar to the last one, except we're not working with 90 degrees. Now this entire combined angle is 106 degrees. All right, they give us one piece, 34. What must the other piece be for this to be 106 degrees? All right, question 3. Similar to question 1. They give us 3 angle measurements, DCE, ECF, and FCG. Here are the measurements. They want us to find the degrees of angle DCF. So DCF. What must that measurement be? All right, a security camera rotates 30 degrees every 10 seconds. How long does it take the camera to rotate 360 degrees? All right, so every 10 seconds is 30 degrees. 60 degrees would be how many seconds? You got it, 20. All right, 90 degrees in 30 seconds. So on and so forth. This is just one strategy. For this question, there are a bunch of different strategies. For question 4, if you have a cool strategy that you want me to explain, that you want me to see, maybe I can explain it to the class if they're having trouble. Shoot me a private message in Google Classroom. That would be awesome. All right. Question number 5, Miss Clark's class went to recess at 12 p.m. as shown below. Here we're at 12 p.m. You can see our clock is pointed at 12. The minute hand had turned 90 degrees by the time recess ended. At what time did recess end? So it turned 90 degrees. Where must the minute hand be now? All right, what's our new time? All right, we have one more time question here. Savannah makes this table to plan her day. Here's her full day. Pretty cool. Just like you guys. You guys are kind of planning your own day now. And it's been really impressive. I've heard some really, really good things from your parents and your other teachers. Part A, the hour hand is at 8 as shown when Savannah starts school. Here we're at 8 o'clock. Boom. The hour hand turns through 150 degrees by lunchtime. How many more degrees does the hour hand turn when it is 8 o'clock again for Savannah's bedtime? So at lunchtime, it's turned 150 degrees. Lunchtime is 1 o'clock, okay? So that means this hand here has to go all the way to 1 o'clock. So that's our angle that's created. They tell us what that angle is. 150 degrees. Then they want to know how much more to get back to 8 o'clock. So think about your circle, think about your full turns, and think about the information that this question gives you. Nice job, my friends. If you have any questions, please reach out to me. I will be providing feedback and grades over the weekend. Very proud of y'all. Good work, and I will catch you next time. Peace.